Okay, so the first step in drawing a Lewis structure is always to first determine how many total number of valence electrons should be in your final structure. So we look at the periodic table. Sulfur is going to have 6 valence electrons. Fluorine is going to have 7, but there are 6 of those in the chemical formula, so we're going to need to multiply that by 6. So the total number of electrons that need to be in my picture here are 48 electrons. Step 2, determine which atom goes into the center. Typically it is the atom written first in the chemical formula, but technically it has to be the atom that is least electronegative. So I know that fluorine is the most electronegative, so as we move away from fluorine on the periodic table, the lower the electronegativity is. So we want to put the atom that is the farthest away from fluorine on that periodic table in the center. So that means for this structure, sulfur goes into the center. Then we're going to draw those 6 fluorines around the sulfur. All right. So I have my 6 fluorines. Okay. Step 3, we're now going to connect the central atom with single bonds to all of the terminal atoms, which are the outside atoms. So we're going to draw single bonds between the sulfur and every single fluorine. Now remember, each one of these bonds represents 2 shared electrons. So I have used a total of 6 bonds. So that means I've used so far 12 electrons, and I need to subtract out those 12 from my total. So we're going to minus the 12 here that we just used in our bond. And so we're going to have 36 electrons left over. So after I subtract out the lines, those 36 electrons are now going to be the dots in our Lewis diagram. So I'm going to start with the outside atoms. They get the lone electrons, i.e. the dots, first until they have their complete octet. So now we're going to draw those lone electrons around every single fluorine, and notice that I'm putting 2 per side of the fluorine. Imagine that there's a square around the fluorine, 4-sided, and each side of that square can get 2 electrons. You would not want to put dots between anywhere near the lines. For example, you would not want to put dots there where the lines are, because then you are confusing that for shared electrons, which is not the case for those dots. Okay, so I have dots. How many have we used? How many lone electrons have we used? We use 6 on each fluorine. 6 times 6 gives me 36. So we have just used 36 dots, i.e. lone electrons. So I have 0 electrons left in my bank. Okay, when I reach 0, that means I have used all the correct number of electrons. You gotta do a final check. You gotta make sure everybody in your Lewis structure obeys the octet rule. So let's start with the fluorines on the outside. Each fluorine has 2, 4, 6, 8 electrons around it. Fluorines are good. They meet the octet rule. Now for the sulfur. The sulfur has 2, 4, 6, 8, 10, 12 electrons around it. Wait a minute. That's more than 8. That's more than the octet rule states. But just keep in mind, sulfur is allowed to have more than 8 electrons because it has empty d orbitals. It is on the 3rd row, so it can acquire more than 8 valence electrons. So this is allowed. This here would be your final answer. This is the Lewis structure for SF6.